Okay. Future value, retirements, IRAs, mutual funds, savings, etc. Anything that's going to come back to you in the future, you hope it will come back more, than less. All your teachers, there's two different types of money we get when we're done. Money's taken out of our paycheck, is put in like a 401k. If anybody works, they get a 401k. Then there's also like a teacher retirement fund that you can put money into, which money also comes out of our paycheck. We get that on top of our 401k. So those are the type of future value things that are come back to us when we're older, and they'll keep paying you as long as you keep living with some of these things. So that's why you gotta be healthy. It would suck to retire and die the next day and all that money. Yes, sir.
Most you get for 401k.
What about it?
41,000.
No, they just call it a 401k. Yeah, that's a legitimate good question. All right, so this is just like the present value formula. All right, but it's future value, and it looks slightly different. Okay, before we had a 1. Was it 1 minus in front of the parentheses and 1 plus? But my minus and 1 are in the back this time. And my exponent is not a negative n, it's just n. Okay? Other than that, the r is still the same. That's like the payment. The n is still the same. Well, we'll find that out. And the I is still the same. So FV, no surprise, that's our future value. And that's what this equation is. All right? R is still the payment in dollars. It's not rent payment, it's payment coming to you from these funds, okay? It's not the total amount you're getting, it's the payment they're making you. It's generally one equal amount, all right? Same thing as present value. The I, it's your rate over the number of payments per year. And what do we say? We were familiar with those two variables. It was a lowercase r over k. Thank you. Because K was quarterly, it was 4 times a year. K was monthly, it was 12 times a year. So, I mean, nothing new. And N. Who remembers what N was for present value?
It was
total number of payments, and the total number of payments. So nothing changes with the variables. You just move really just the -1. There was a 1 minus in front, not the 1 minus 1 in the back. And my N is not negative. It's positive. And that's it. And again, if you were to do a test on this, I would make sure you had all the equations. You just have to know which one to use for which case. Here we go. Here's an example. At the end of each quarter, Emily puts $500 into a mutual fund. If her investment earns 7.88% annual interest compounded quarterly, what will be the value of Emily's annuity in 20 years? So they want to know what's the value, okay, in 20 years. All right? We need to find our future value, don't we? So, we have future value equals, in parentheses, 1 plus my I to the n minus 1 all over I. The R is in with the the capital R. Good.
Oh, come on.
It is. I gave my last one to Cameron on Friday, so that is R times that whole parenthesis. Okay? R times that whole parenthesis. Now, we're going to figure out what's what. We know we're solving for FV, future value. So what is my R?
500.
Yeah, 500, because she's putting in $500, right? Into a mutual fund, so it's 500. Right? What about her investment? Right. Her I, her interest is R over K. And our rate, you said it, was 0.0788 over 4. Why do we know it's 4? Quarterly. That means K equals 4, so it's 4. This is your little R, your rates. Of course, we need to make that a decimal. It can't be a percentage. This is your capital R, in case you haven't been following along. Capital R, right there. So, So, we have our R, we have our I. Last thing, careful. It's not the total years, it's the total payments, right? How do we know it's 80?
4 times a year to 20 years.
She's paying at the end of each quarter, right? Which means she's paying 4 times a year. That's what she's putting in. Every 3 months is a quarter. Okay? Not 4 months. Don't make that mistake. It's 3 months is a quarter of a year. Okay? So, if every quarter for 20 years, well, that means 4 times a year, 4 times per year for 20 years. So 4 times 20 gives you 80. Nice. 80. So I will stop. I'll let you guys plug this in so you get the answer, and then we'll go. All right. Let's see who got what answer. Let's see if you guys did this right. Let's plug our numbers in. So my FB, my future value, is going to equal my R, which is 500. Times. Okay. Big fraction here. 1 plus I. So it is 1 plus my I right here. It is 0.0788 over 4. All right, that is raised to the n, which is 80. And don't forget we subtract 1 extra. All over I again, which is 0.0788 over 4. And that's it. You put in the calculator just like that. Now, you guys need to be very careful with the way you put this in the calculator because of order of operations. All right? Meaning, when I start this, I'm going to put 500. Okay? There's my parentheses. My fraction goes in here. So I always do this. This helps separate things. Now, on the top half of my fraction is another fraction, isn't it?
Yeah.
Okay? So I've got to do another fraction right away on top. And it is, 1 plus that fraction. I got a little ahead of myself. And that's 0.0788 over 4. I'm going to put that in parentheses. Bam. Why am I putting it in parentheses? Yeah, I got to put it to the exponent of 80. So I need to put my exponent 80, top off the exponent. Don't put the minus 1 with the exponent. Minus 1. Now I got to go all the way to the bottom, and it's over another fraction. Okay, so I'm going to do another fraction. Alpha y equals enter. And there's my 0.0788 over 4. Go all the way to the end here, and I close that out. That might seem like a lot to type in, but that's a lot of work, but let the calculator do it. What did some of you have as an answer? 508.3. That right there? That is good work. So let's do this here. And let's just take a look at, a value. If this is money, I'm going to say that total would be what? 95,483 and what? 39 cents. Don't forget, we're rounding that penny up. It wouldn't be 38, we rounded to 39. So, she pays $500 each time, correct? How many times does she pay $500? 80. So in your calculator, what is 500 times 80? It's 40,000. There's 40,000. And look how much her account is. Now, of course, that's 20 years later at an interest rate of 7.88%. But now you know why people take money out of their paycheck for 20 years? And just put a little bit here, keep on adding and adding and getting it in there. You want that money to raise. The more money you put in, the more it'll accumulate over time. That's a valuable thing to know. All right? But of course, if she would have taken it out and spent it, it wouldn't have been as high. All right? So, Homer, section 3.6, 14 20s evens, 48 to 56 evens. That is it for this lesson.
Hey.